What's up, Coach Snow's geometry class? Today we are beginning Unit 8, which we are going to be talking about everything about two-dimensional shapes and their measurements. So anything from finding the area, to finding the perimeter, to finding something called the angle-sum theorem, to the apothem, all this stuff dealing with two-dimensional shapes. So let's get started. Alright, so the first thing we're going to look at is 8.1, which is known as the Polygon angle sum theorem. So we're going to learn a couple of things whenever we're given some type of shape, whether it be a rectangle, a square, a triangle, anything, a hexagon. There's a formula you can use to find out what all the angles add up to. So what this formula is, to find the sum of the angles, S, I'm going to take N, which is the number of sides. I'm going to subtract 2 and then multiply by 180, and when I do this it gives me what all the angles add up to. Okay, so if I was given a regular polygon, what I'm going to do is I'm going to do the same formula. So if we look over here to find the interior angles, I'm going to do n minus 2 multiplied by 180, then I'm going to divide by the same number of sides. So that's going to give me the number of sides, or what one of those angles is going to equal. Okay, so the next thing is we're going to look at the exterior angle sum theorem. So if I was to extend every single line inside a polygon, and if we look, do y'all see where angle 1, so I'm going to circle it, angle 2, angle 3, 4, and 5, you see how they're on the exterior of this side? So I know also all of these angles, if I were to add them up, they are always going to add up to 360 degrees. So if I have a regular polygon, if I take 360 and divide it by the number of sides, it's going to give me one of those sides. Okay? So now let's just look through some vocabulary here. So the first vocabulary we're going to look at is, of course, the definition for a polygon. And the definition for a polygon is a closed plane figure with at least 3 sides that are segments. The sides intersect only at their endpoints, and no 2 adjacent sides are collinear. So basically any shape that has straight lines and is enclosed is a polygon. So first look at this first one. Of course, A, B, C, D, E is an enclosed shape with just straight lines. So of course it is a polygon. So the next one, of course, is not going to be a polygon, because if you look, if we go all the way around, it is missing a side, so it's not closed. So it is not a closed figure. So this would not be a polygon. And then the last one, if you look, it is technically a closed, but if we look here, we have 2 lines that are crossing each other. So this makes it not a polygon, because 2 sides intersect between points. So that means since these 2 intersect, that means it's not going to be a polygon. Okay? Okay, so now we're going to continue on through our vocabulary, and the first thing we're going to look at is a convex polygon. A convex polygon does not have a diagonal with points outside of the polygon. So if you look at this polygon on the left side, does everybody see the dotted lines? We have a dotted line connecting from A to T. We have a dotted line connected from D to T. R to Y, R to D, and A to Y. So if you look at all these lines being connected, all of those points on that line are inside of the polygon. So none of those points are outside. So that's what makes this a convex polygon. So basically all the points are going to be exterior to those diagonals. Okay, so the next we're going to look at is what a concave polygon is. A concave polygon has at least 1 diagonal with points outside of the polygon. So if you look here on this polygon to the right over here, we can look at line MW connecting these points together. And if you look at this line, these points are going to be actually outside of the polygon. So that means this has at least 1 diagonal that is outside of the polygon. So that is going to make this a concave polygon. Another way that I like to think of this, if we look at this section right here, it's actually going into the polygon, which is like a cave. So it's concave. So that makes it a concave polygon. Okay, and lastly, we're looking at the definition of a regular polygon. And I want you guys to really pay attention to this definition because we're going to be using this definition a lot throughout throughout this unit. So a regular polygon is both equilateral, which means all sides are congruent, and it is equiangular. Equiangular means all of the angles are going to be congruent. So inside of a regular polygon, and it'll actually put it inside of a problem, it'll say regular polygon is both equilateral and equiangular. So let's go ahead and start on our examples. So first example here, it says to classify the following polygons as convex or concave. So earlier, looking at the definition, this first one is going to be a star. And obviously you guys are probably going to look at it and be able to see, if we look, all of these points are going into the shape. So that is going to make this a concave polygon. So the second one here, if we look, all the points are going to be outside of the polygon. So if I was actually to draw diagonals going from each one of these points, every single one of those points are going to be inside of the polygon. So this is going to be a convex polygon. And then the last one, of course, if you look here, we have two angles, or an angle basically going into the shape. So this is going to be a concave polygon. So let's look at example number 2. And what example number 2 says is find the sum of the measure of the angles of a decagon. So if you guys were to look up, deca means 10 sides. So in order for me to find the sum of the angles, all I have to do is use the formula S is equal to the number of sides minus 2 multiplied by 180. So let's go and do this. So the angle sum is going to be 10 minus 2 multiplied by 180. 10 minus 2 is going to equal 8. And then 8 times 180 is going to equal 1,440. So what that means is all the angles of a decagon are going to add up to 1,440 degrees. Alright, so let's look at example number 3. So it says we need to find the measure of angle X in the quadrilateral X, Y, Z, and W. So we automatically know that in a quadrilateral, all of the angles add up to 360 degrees. And so if you look here, angle Y and angle X are going to be congruent to each other. So we can represent those as the same variable. So right here, I know angle Z is 90, so I know 90 plus angle W, which is 100, plus angle X, which I want to represent that as X, and angle Y, I want to represent that as X as well because they're congruent, is all going to add up to 360 degrees. So now I'm going to combine like terms and I'm going to solve for X here. So 90 and 100 are going to add up to 190. X and X are going to add up to 2X. I'm going to subtract 190, which is going to give me 170. And then I'm going to divide by 2, which is going to give me 85 degrees. So that means angle X and angle Y are both going to add up to 85 degrees because of this up here. Okay. And then lastly, look at number 4 here. It says for a regular 8-sided polygon, we need to find, or also an octagon, we need to find the measure of the exterior angle. So earlier we know that all the exterior angles of any regular polygon add up to 360 degrees. So in order for me to find one of those, all I have to do is divide by the number of sides. So on this it tells me that it is an 8-sided polygon, so all I have to do is 360 divided by 8. So 360 divided by 8 is going to give me 45 degrees. So that tells me all the exterior angles of a octagon add up to 45 degrees. Alright, so for example number 5, it's kind of doing the same thing as it did on example number 4. So for a regular 20-sided polygon, we need to find the measure of an exterior angle. So again, I know all the exterior angles of any polygon are always going to add up to 360 degrees. So literally all I have to do is 360 divided by the number of sides. So I'm going to do 360 divided by 20. And if I type this in the calculator or divided it out, it would be 360 divided by 20 would be 18 degrees. So that means every exterior angle of a 20-sided polygon add up to 18 degrees. Okay. All right, so let's look at number 6. So on number 6, it says the sum of the measures of the angle of a given polygon is 720 degrees. How many sides are in the polygon? So I know the angle sum theorem is S equals the number of sides minus 2 multiplied by 180. So I'm going to use this formula and basically work backwards to find the number of sides. So I know S in this problem is going to be 720 degrees. So I'm going to plug 720 in and I'm going to solve for N. So 720 is equal to the number of sides minus 2 multiplied by 180. So all I have to do is work my math here and solve. So I'm going to divide by 180. So 720 divided by 180 is going to equal 4. And then all I have to do is add 2 on both sides. So N is going to be equal to 6. And then lastly on number 7, it says pentagon ABCDE is 5 congruent angles. We need to find the measure of each one of these angles. So I know that if I have a pentagon, that means I have 5 sides, right? So that means I need to find the sum of the angles, and then I'm going to divide that by the number of sides. So I'm going to do the problem S equals N minus 2 multiplied by 180. S equals N minus 2 multiplied by 180. I have 5 sides, so S is going to be equal to 5 minus 2 times 180. So 5 minus 2 is 3. 3 times 180 is going to give me 540 degrees. So now what I have to do is I have to take that 540 degrees and I'm going to divide it by the number of sides, which is going to give me one of those angles. So I'm going to do 540 divided by 5. So 540 divided by 5 is going to give me 108 degrees. So one angle inside of a regular pentagon is going to equal 108 degrees.